Hi everyone, I am JULKA. Today's topic is regression line. Here we talk about linear regression. First we talk about y on x. Y equals to a plus bx, where a and b are determined using equation summation of y equals to an plus b summation of x, summation of xy equals to a summation of x plus b summation of x square. After solving second and third, we will get the value of a and b, where b is n times of summation of xy minus summation of x summation of y divided by n summation of x square minus summation of x whole square. Y bar is summation of y upon n and the y replaced by a plus bx, which equals to a plus b x bar. Take this as a fourth equation. Now subtracting fourth from first, and we will get y minus y bar equals to a plus bx minus a plus bx bar, which equals to y minus y bar equals to b times of x minus x bar, where b is equals to n times of summation of xy minus summation of x summation of y divided by n times of summation of x square minus summation of x whole square. We can say it is byx. So y on x is y minus y bar equals to byx times of x minus x bar, where byx is regression coefficient of y on x. Similarly, we can calculate x on y. X minus x bar equals to bxy times of y minus y bar, where bxy equals to n times the summation of xy minus summation of x summation of y divided by n summation of y square minus summation of y whole square, and bxy is the regression coefficient of x on y. Example first. Using following information, find regression lines y on x and x on y. N is 5, summation of x 15, summation of y 25, summation of x square 55, summation of y square 135, and summation of xy equals to 83. X bar is summation of x upon n, which equals to 3, and y bar is summation of y upon n, which equals to 5. Now byx is n times of summation of xy minus summation of x summation of y divided by n times of summation of x square minus summation of x whole square. By inserting all the values and after calculation, the answer of byx is 0.8. Now we calculate bxy using formula n times the summation of xy minus summation of x summation of y divided by n times the summation of y square minus summation of y whole square, and after putting the value we will get bxy equal to 0.8. Now first we calculate the regression line y on x, which is y minus y bar equals to byx times of x minus x bar, and after putting the value and simplification we will get y on x y equals to 0.8x plus 2.6, and the regression line x on y is x minus x bar bxy times of y minus y bar. After putting the value, we will get regression line x on y as x equal to 0.8y minus 1. Now next example, when you want to find out the regression line when the values of x and y are given to us. Find equation of two lines of regression from the following observations: 3, 6, 4, 5, 5, 4, 6, 3, and 7, 2. And find an estimate of y for x equals to 2.5. So first of all, x and the value of y's are given. Here n is 5 pairs. X is 3, 4, 5, 6, 7. Y is 6, 5, 4, 3, 2. We just calculate x square, y square, and after that we'll calculate x into y, and the sum of all, sum of x's 25, sum of y 20, sum of x square 135, sum of y square 90, and sum of xy is 90. X bar is summation of x upon n, which is 5. Y bar is summation of y upon n, which is 4. And now byx is n times of summation of xy minus summation of x summation of y divided by n times of summation of x square minus summation of x whole square. And after calculation, we will get byx equals to minus 1. And bxy is n times the summation of xy minus summation of x summation of y divided by n times the summation of y square minus summation of y whole square. After putting the value, we will get bxy equals to minus 1. Now regression line x on y is x minus x bar bxy times of y minus y bar. X bar is 5, y bar is 4, and the bxy is minus 1. So value of x is minus y plus 9. And regression line y on x is y minus y bar byx times of x minus x bar. Y bar is 4, byx is minus 1, and x bar is 5. So the value of y is minus x plus 9. For x equals to 2.5, y is minus 2.5 plus 9, which equals to 6.5. So the estimated value of y is 6.5 when x is 2.5. Next example, find y on x and estimate y when x is 24. Value of x are given, value of y are given. There are 10 observations and the x and y values are big. So first we take x, y, then we calculate x bar. X bar is summation of x upon n, which equals to 16. And y bar is summation of y upon n, which equals to 18. So first of all, we calculate x minus x bar. X bar is 16. So 20 minus 16 is 4. 13 minus 16 is minus 3, and so on. Similarly, we calculate y minus y bar. Y bar is 18. 17 minus 18 is minus 1. 12 minus 18 is minus 6, and so on. We'll calculate y minus y bar. After calculating x minus x bar and y minus y bar, we'll calculate x minus x bar whole square and y minus y bar whole square. And also calculate x minus x bar into y minus y bar. And the sum of all is 110 of summation of x minus x bar whole square. 254 is the summation of y minus y bar whole square, and 125 is the summation of x minus x bar multiplied by y minus y bar. Now byx is summation of x minus x bar multiplied by y minus y bar divided by a summation of x minus x bar whole square, which equals to 25 by 22. Now regression line y on x is y minus y bar equals to byx times of x minus x bar. Y bar is 18, byx is 25 by 22, and the x bar is 16. And after calculation, we will get y on x as 25x minus 22y minus 4 equal to 0. At x equal to 24, value of y is 298 upon 11, which equal to 27.09. If in this question we want to calculate x on y, so first of all we will calculate bxy, which equals to summation of x minus x bar into y minus y bar whole divided by summation of y minus y bar whole square. We will apply this kind of formula only when the value of x and y are very big.